All right, welcome to the Chapter 5 test review. So where you can get this attendance link or the YouTube links from your digital classroom is if you go to classwork and you find your Chapter 5, you can look for the Chapter 5 test review. If you open this up, you will see the items I'm going to use today. So again, your attendance, you can download the digital copy for the review. There's the YouTube videos. And today I'm sure I'm going to be using some calculators. So I'm going to open that up. I'm going to open up the formula chart. And a unit circle, you could open up this link. And now I'm not going to use this link just because I have a different one that I'm going to copy over when I need it onto my notebook file over here. Okay, so if any point in time you're listening to this video and you want to stop and take the test, feel free to do so. For everybody else, I'm going to walk our way through this Chapter 5 review. It'll be hard for me to go in detail over every single problem. Okay, so I'm going to just kind of pick and choose throughout the problems. There's 4 different pages of problems, if you will. So there's 20 problems, and on the 4th page we'll get to the last. All right, I'm going to kind of pick and choose my way through as we go. If you want more detailed for each and every problem, again, go to the YouTube playlist and you'll see them listed there. All right, so I'm going to start with number 1. Here, when it talks about converting degrees to radians, what you need to remember when we convert degrees to radians is that 180 degrees is equivalent to 1 pi. Now, if you want to get this more in detail, this is left from lesson 4.2. So I'll put the lesson over here. This is from lesson 4.2. And we learned that 180 degrees was equal to 1 pi. Okay, so the way to convert, if you think about like in sciences, I think sciences do a great job, at least my science teachers did, of teaching conversions. That what you're doing is you're ultimately multiplying by 1 as a fraction, but the 1 doesn't look like 1, it's a conversion. And so we're going to multiply by pi divided by 180 degrees. And the reason we do this is because if I'm multiplying by degree symbol and dividing by the degree symbols will be eliminated and we can get our solution. So unsimplified, it would be 785 pi over 180. Now I know 5 goes into both of these, but what I'm going to do is I'm going to go over to Desmos. So I'm going to go to my Desmos graphs here. I'm just going to, I think I made a conversions. If you go to spring semesters, radians and degrees, convert. Yeah, I made one of these. So let's open that up. And it shows you that same relationship. So what you can do though is you type in 785 divided by 180, and it can reduce this as a fraction by clicking this fraction button right there. So we get that's 157 over 36 pi. So I'll write it, typically we actually write the pi in the numerator, so I'll say 157 pi over 36. And that would be our solution. Okay, so I did not type in the pi over here to the calculator. And so therefore, when I wrote my answer, I needed to add in the pi. Okay, now let's talk about converting from decimal degree form to decimal, from degree minute seconds form to decimal degree form. And so if you look over here in the conversions, 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. That's what those symbols refer to. One little apostrophe there, little tick mark is referred to as a minute, and 2 referred to as seconds. So here's the way we do this. I know that my answer is going to be 39 point something degrees. So it wants it in decimal degree. That means just as a decimal. And so we'll have some decimal amount of degrees. So how do we figure that out? Well, what I'm first going to do is start with my minutes. Say, okay, 59 minutes. And again, I'm going to walk through the same conversion I did up here, where this time we're going to say 1 degree is equal to 60 minutes, or 1 minute is equal to 60 seconds. So since I'm converting seconds, how I want to start this is I'm going to say, okay, 59 seconds, I need to convert that to minutes. And so there, for every 60 seconds, there is 1 minute. And so we multiply this out, and we get that we have 59, those symbols go away, 59 minutes over 60, 59 over 60 minutes. And we could get that as a decimal, but I'm going to wait here and say now I have 12 additional minutes I'm going to add to that. So I'm going to add 12 full minutes, which means basically I have as an improper fraction 12 and 59 or 60 minutes. That says an improper fraction, which you can do that on decimals as well by just pressing the space. 12 and 59 divided by 60. I believe, yeah, if you check this out, watch this. 12 times 60 is 720. And if I add the 59, there it is as an improper fraction. There it is as a proper fraction. So it did work. So you just put a little space in there. What I'm going to do to convert this is I'm going to multiply. I'm going to say 12 and 59 60th minutes times, and now I want to get rid of minutes and go to decimals. So I'm going to go 60 minutes is 1 degree. I think I said decimal. I meant to say degree there. So 1 degree is equal to 60 minutes. So I'm now using that conversion. And so I'll multiply that across. So I'm going to take this, and just to make sure I do this correctly, let's put a parenthesis around that. And I'm going to multiply this times 1 over 60. Now notice my symbols there go away. And this is my decimal, or my fraction here. And I'm going to write this as a decimal because that's what we're supposed to get it to. And it looks like it's a bunch of 8s repeating. That's just a rounding off there. And so it's 0.21638 repeating, which equals 0.21638 repeating degrees. This says round to the nearest thousands, which means 3 decimal places. So it'd be 39.216 degrees. And that would be our solution for number 2. This was also lesson 4.2. If you want to go get that more detail. All right, number 3. Again, I'm going to just some of these I'm going to skip as we go over. But on number 3, it says given that sine is negative 20 over 29. Now what I'm going to do here is I'm going to switch calculators for a moment. I'm going to go to the basic trigonometry because I'm going to use a relationship that it's got over here. It says that sine is negative 20 over 29. Well, it's helpful to know that sine is y over h, and it's also helpful to know that h is always positive, which means if I do a little substitution here. Okay, sorry about that. So I'm going to do a substitution where sine is y over h. So I'm going to rewrite this saying that y over h is equal to, now h is always positive, so that negative has to go with the y. And it says cosine's positive, which cosine, if you look over here, is x divided by h. So x divided by h has to be positive. And we know that h is 29. So x over 29 has to be positive. And if I wanted to solve for x here, I can multiply both sides by 29. And lo and behold, what I find out is that x has to be greater than 0. And so now you could do Pythagorean Theorem to get your x, because remember, this is referring to x, y, and h, kind of like a triangle. These follow Pythagorean, so x squared plus y squared equals h squared. So if I wanted to solve for what x actually is, I would say x squared plus y squared equals my hypotenuse squared, where x is unknown, but my y is negative 20. I'm going to put that in parentheses to make sure I square the negative, and h is 29. So we go to my calculator. Let's find out what negative 20 squared is. That's 400, and 29 squared, this I don't have to put in parentheses since it's not negative, is 841. So what I'm going to do, just to save a little space, is I'm going to subtract here 400. I'm just going to write 400 because that's what that is. So that goes away. And we find out that x squared will equal, when I subtract those, 441. I'm going to take the square root of 441. Normally, I would say if you add a square root that's not originally there, it needs a plus or minus. But this one, we don't need a plus or minus. We know it's positive. So x will be the square root of 441. So SQRT is square root code 441. The square root of 441 is 21. X equals 21. Now that I know X, Y, and H, I can fill out the other 5 remaining trig functions. So cosine is X over H, so it'd be 21 over 29. Tangent would be Y over X, Y over X. So it'd be negative 20 over 21. Cosecant would be the reciprocal of sine, H divided by Y. Secant would be the reciprocal of cosine, so it'd be H divided by X. And cotangent is the reciprocal of tangent, so it'd be X divided by Y. And those would be my values there. All right, number 4, I'm going to go ahead and skip this one. This would follow the Pythagorean, where we don't know our X, but we do know Y is, it says 410. Why does it say 410? My guess is when I copy this, something's off. So treat that as a 10 and this as a 12. I don't know what it was saying. It looks like the, let me actually fix it this way. It looked like the Y value was greater than the hypotenuse, which is impossible. So let me just put some white spots and you could solve that problem from there. Okay, so I'll let you solve that one. But I'm going to move on. Oh no, this did not print right here. It says a sector, let me see, hang on one moment. All right, I got the new picture for us. It says a sector of a circular patio intercepts an arc that is 13.2 meters and has a central angle of 132 degrees. Find the diameter of the patio. And I want to tie in a couple things to you. I want to remind you that when we started learning about radians on lesson 4.2, oh, it just occurred to me I didn't write the other lessons on this stuff here. By the way, number 3, you would have gotten this on lesson 4.1, but even more in detail starting on lesson 4.3. So I'll put 4.3 there. This one would be 4.1. It's pretty basic. Okay, so on 4.2, we started learning what is a radian, and we learned that 1 radian, it's instead of using degrees, what a radian is when the radius matches the arc length or the intercepted arc. So this one is giving us a value of 13.2 meters, and we can tell just looking at it is greater than the radius. So this is not 1 radian, but they gave it to us as a degree measure. The formula that we learned on lesson 4.2 is that if you're working in radians, it's very simple, where they're going to call the arc length the S, and this would be obviously the radius, the R. They'll say, and this would be the theta. Let me go ahead and click that in there. They would say to calculate radians, you use the formula S equals your radius times the angle. And that's how you would calculate radians. But we had to throw in there, not always are we working in radians. Sometimes we're working in degrees. And so we had to do a conversion in there. And so S would equal R theta, but remember this is in degrees. And so to convert from degrees, it'd be what we did earlier, is you'd multiply by pi and divide by 180. And this would cancel this degree symbol. So the degree symbols would end up simplifying out of this problem. Right there and there. And so we'd have R theta pi over 180. But for now, I'm going to leave the symbols there so you can see that they will cancel out. Let me, whoops, erase too much. Let me try this again. R theta pi over 180. All right, so now let's look at our problem and see if we can solve this. We are given the S value, the arc length, the intercepted arc. And so that's going to go on the left side of our equation here. And we'll do a little algebra in a second. So we have 13.2 meters equals, and just remember that's meters because that's going to come into play later, equals, we don't know the R, but we do know theta is 132 degrees. And I'm going to multiply by times pi and divide by 180. Once again, we'll see that these degree symbols simplify out. And so I can do a little math here. What I'm going to do to solve for r is I'm going to do the opposite. I see it's multiplying by 132 and multiplying times pi. So what I'm going to do here is, and dividing by 180. I'm going to, hang on one second, let me go shut my door. All right, so let me say this again now that I don't have the hallway noise. Since r, I'm trying to solve for r, that's our unknown variable, and so we do the opposites. That's what we learn in algebra, and so it's multiplying by 132 and multiplying by pi, but dividing by 180. What I'm going to do is the opposite. So instead of dividing by 180, I'm going to multiply by 180. Oops, where'd the one go? There it is. Multiply by 180, and I'm going to divide by 132 pi. So what's going to happen, I need to do this on both sides of the equation, because what I do on the left, I got to do on the right. Or I said that backwards. What I do on the right side, I need to also do on the left. And so now I can look at it, and those will simplify, these will simplify, that will simplify, and we'll have our r value. Okay, so let's go to our calculator. Let me clear off some of this. So we're typing in 180 over 132 pi times 13.2. That's going to be our radius right there. So all of that simplifies to become basically 5.729. I'm going to say 296. So I rounded the nearest 10,000. That is approximately our r because I rounded it. Now remember, diameter is equal to 2 radiuses. D equals 2r. 2 radiuses equals the diameter. So if I multiply that by 2, so if I take this value and I just multiply that by 2, we get our answer. And this would be in meters. So I need to put a meter right there. That's in meters. And so I'm going to say that my answer is approximately, we'll just round to the nearest thousandth here, 11.459 meters. And that would be my solution. It's number 4. All right, now let's do a number 6. Now coterminal, I believe also is lesson 4 too. Coterminal, if you remember by definition, terminal means where something ends. Coterminal means they end together. And so what's really happening here, I'm going to show you by way of looking at a circle, is that you have an angle that's negative 85 degrees. So let's just say we start, here's the initial side. So the terminal side for negative 85 degrees is almost straight down, because that would be negative 90 degrees. So it's somewhere in here. Let's just say that right there is negative 85 degrees. So this starts at 0 degrees. Going downward is negative 85 degrees. Okay, so it's basically what this is trying to ask us is, what is the coterminal that's between 0 and 360? What would be the angle that ends in the same location but went around the circle this way? That's what we're trying to find. Well, the thing about coterminal that's always so easy is it's always one full revolution. And remember, a full revolution is either 2 pi or 360, depending on what your units are. Since I'm working in degrees, it would be 360. So I shouldn't say 0 equals, because they're coterminal. I'll just say 0, 360. Those are both the same location. And so how I would do the math here that's involved is you just take your angle and you would add 1 revolution. So I'm going to add 360 to get our solution. And so to make sure I don't do bad math, let's just check it over here. Negative 85 plus 360 is 275. So it'd be 275 degrees. And so what we've learned is that to find a coterminal, you take your angle and you plus or minus 1 revolution at a time until you get the angle that's in between the restriction you're looking. We were looking for something between 0 and 360, 275 was. So really what you do is you take your angle for coterminal here. Here's just the rule for coterminal. You take your angle and you add or subtract a revolution. And you just keep doing so until you find an angle That's within the restriction you're looking for. So that's it for the first page. I did 5 out of 6. Let's go on to the second page here. I told you we had 4 of them. On chapter 5 test number 7 says find the exact value of cotangent secant inverse 11/9. And this is from lesson 4.6. This is called composition of functions. Composition means you have a function within another function, or where you have one function, its domain is made up of another trigonometric function. That's composition with trigonometric functions, okay? So here's what this is telling us. For secant, I looked over here, secant is h over x. What we're learning right here is that that's h, this is x. Okay, now with cotangent, it's saying find me the x over y. So my answer is going to be x over y. Now we already know x, which means I already know my answer's got to be 9 divided by something. Okay, that's what I already know about my answer, because that is cotangent. Cotangent is x over y, and that's ultimately what we're looking for. So that's why I know that portion. All right, so let's come back over here, and we could say we got to do Pythagorean Theorem, and you know what? That would be perfectly accurate, because all we need to get from this moment is we need to get our y value. But one thing before I say that, if you remember with inverses, anytime we're dealing with inverses, and I showed you this by way of a unit circle on the lesson, if you start with an inverse, what immediately happens is half your domain is restricted. A inverse only exists on a certain portion of the domain. With cosine and secant, for this family of functions, if you will, the restricted domain eliminated this portion of the graph. So the restricted domain went from 0 radians to pi radians, and anything in between in there. Okay, the only thing different with secant is it doesn't allow for a 0 or, no, I'm sorry, it does. So it goes from 0 to pi. Anything in here is an acceptable answer. So what does that mean for our y values? Our y value has to be positive because we've restricted out the negative y's. So when I do this, I'm not going to do plus or minus for my y. I'm going to state it that it has to be positive. So we're going to follow the Pythagorean theorem, which says x squared plus y squared equals my h squared. And we'll substitute in our values. We know x is 9. We don't know our y other than it's positive. And I should have made that note right here. Y is greater than 0. That's what we learned. Okay, and so back over here, h is 11. For the sake of time, I'll just tell you, 9 squared is 81. 11 squared is 121. So we subtract our 81s, and it looks like y squared is going to be equal to 40. Okay, and so let's simplify that. Now, normally when we add a square root, I need to add a plus or minus, but we know it's got to be positive. So I just need to simplify the square root of 40, which I know that I could rewrite that as the square root of 4 times 10. And we have a square root of 4. It's 2. So I'm going to say it's 2 squares of 10. 10 could be broken down into factors of 2 times 5. But since it's not a pair, I can't pull it out. So that would be the solution there. For my y, it would be 2 square roots of 10. If I'm not going to leave a square root in the denominator, I would need to shoot that up, which means it's 9 square roots of 10 over 2 times 10 is 20. And that would be my solution. 9 squares of 10 over 20. We can check it out over here. Let's type this in. Let's check our answer. Cotangent of secant inverse. And you need to use a parenthesis on Desmos. You need to use a parenthesis. I'm going to switch this. I don't know if it matters, but put it in radians. Unfortunately, it's not giving it to me as a fraction. Oh, that's because of the square root. What am I thinking? Okay, so let's test our answer. 9 times the square root of 10 divided by 20. Looks like we did our good math. Answers match up. So we did that correctly. All right, now number 8, we already did one very similar. Very similar. I did this on number 3. So I'll just let you know this is like number 3, and it was found off of lesson 4.3 here. So I'll just say like number 3. And you can go back and look at that one. Remember, h has to be positive, so the negative is going to go with the y. That's actually a unit circle value. Okay, so I'm actually, you know what? I'm going to solve this real quick just because it's a unit circle. We haven't gotten to use a unit circle today. How do I know it's the unit circle? Well, I notice it's a negative square root of 3 over 2. That is a value that I can find on my unit circle. So let me actually just, this is going to be, I'm going to add this in really small, but you can't see anything. So let's do this. I'm going to go back and I'm going to add a new page and do it really large. How about that? So here's what we know. It says sine theta equals negative square root of 3 over 2, which implies that sine inverse would be negative square root of 3 over 2 would equal your theta. Because remember, with the inverse, you exchange or substitute your domain and range. And so what I'm looking for is a negative square root of 3 over 2. Now, it didn't start as an inverse, so I can't eliminate half my, or restrict half my domain like I normally could with sine. You normally restrict this side, but I can't do that. So I know, so I'm looking at the y. Remember, all points here are listed as, I forgot to see, cosine theta, sine theta, all of these points. So I'm looking in the place of y's. These are positive y, so it won't be up top. It's going to be down low somewhere. I did not restrict. I'm just showing you it's not up there because it's a positive y. So I'm looking down here. It looks like this is sine value, negative square root of 3 over 2. Comes from 4 pi over 3. Here's another one. Comes from 5 pi over 3. The problem told us something else that's very important. It said that secant is greater than 0. Said secant theta is greater than 0. Now remember, a lot of announcements today. Okay, so secant is greater than 0. So secant is h over x. H over x is greater than 0. And since I know h is 2, we're going to say 2 over x is greater than 0, which I don't know how else to do the algebra here, other than to say, you know, what I can do is I could divide both sides or multiply each side by a half. And what I learn is that 2 over x is greater than 0, or excuse me, 1. I forgot to, there we go. 1 over x. I don't know how else to say this other than to say it's the same if you took the reciprocal, that on this case, x over 1 would also have to be greater than 0, which means x is positive. So it's not this angle over here because x has to be positive. That's what I'm learning right here, is that x must be greater than 0. And so for that reason, this side of the graph's eliminated. This has to be your solution right there. Theta would equal 5 pi over 3. So when I come back over here, the answer would be 5 pi over 3. And I got all that from the unit circle. Okay, you could do it like number 3, like I did earlier, but there was doing it with the unit circle. All right, number 9. This is the first problem that comes from chapter 5. Specifically, this is chapter 5, lesson 4. It says if tangent alpha, that's an A for alpha, a Greek letter A, is 12 over 5 and is located in quadrant 1, and secant beta is negative 25 over 7 and located in quadrant 3, find cosine alpha minus beta. Well, let's go to our formula chart real quick. And remember what that formula even means. If it says cosine, find cosine alpha minus beta, that means I need to use this formula right there. It's not really letting me highlight very well, but it's this formula. So what I'm going to do is copy it down. Cosine alpha minus beta will equal cosine alpha, I'm going to just do a normal A, English A here, times cosine beta plus sine alpha times sine beta. So that's what I have there. Now let's talk about our alpha and beta. Here's what I know about A. A, it says tangent A is 12 over 5, and it's located in quadrant number 1. Let me come back over here for a second. So tangent is y over x, and it's located in quadrant 1, which quadrant 1 means both my y is positive and my x is positive. So for, let's call it A, and I'm going to do a apostrophe here. What I know is that y and x have to be positive. X equals positive 5, y equals positive 12. If you did Pythagorean theorem, I'm just going to tell you, this is a Pythagorean triplet. Your h is going to be a great number. It's going to be the number 13. It's no decimals. That's what it's going to equal if you do Pythagorean theorem. Okay, so you can do right there Pythagorean. I'm just going to make a note. I just did it in my head for the sake of time. Now over here, we have beta. Let's talk about beta. For beta, it says it's located in quadrant 3. Now, I want you to think in quadrant 3, x is negative and y is negative. The rule is h is always positive here. So secant, it says, is h over x. So we know the x has to be the negative 7. I'm going to skip my y for a second. It's also a Pythagorean triplet, but it's not one as commonly known. And h is positive 25. Now, if we do a Pythagorean, we're going to find out y is 24. Now, let me check that really quickly because it's, again, like one we don't see as frequently. Let me make sure that's right. So I know negative 7 squared is 49, and 25 squared is 625. So I'm going to subtract that, and I get 576, and the square root of 576, yep, it is 24. Okay, so I was right in saying this value is a 24. So how do I solve this problem? Well, I plug in the ratios as we go. I'm going to slide this over just a tear. Okay, so we plug in the ratios as we go. So cosine of A, that would be 5 over 13 because cosine is x over h. So for the a's, it would be 5 over 13. So 5 over 13 times cosine B would be negative 7 over 25. I'm putting that in parentheses so that I remember I'm multiplying by a negative plus sine A, 12 over 13, times sine B, 24 over 25. I can see I have a common denominator, so that's nice. So our denominator will be 13 times 25, whatever that is. 5 times 7 is 35, so 5 times negative 7 is negative 35. And then 12 times 24, not sure what that value is. 12 times 24 is 288. And we could simplify all this, and I'm just going to use Desmos to help me out. For the sake of time here, let's just see. Negative 35 plus 288 over 13 times 25. As a fraction, that would be 253 over 325. That is cosine of alpha minus beta would equal that a number right there. All right, let's check out number 10 here. It says simplify this. Now I know it's hard to see, but this says cosine times tangent. Let me see if I can zoom in just a little bit more. Oh, that may be too big. Actually, no, I'll do it like this for a second. So this comes from lesson 5.2 when we were doing our spot oil. I gave you that learning technique. I was saying, hey, use spot oil to help you solve this problem, where S stands for try to simplify. P stands for if you can't simplify through algebra, try Pythagorean identities. If you can't do that, try to do what's called an opposite, what I call an opposite denominator. It's honestly a conjugate. T is to transform things to sines and cosines. And then if none of those work, try the other identities listed, which one of them we just did up here, the sum or the difference identity. The other two were cofunction and even odd identities. So when I come over here, let's try to solve it. I'm looking at it and I say, can I simplify? Can I cancel anything right now? It doesn't look like it. I say, okay, what about Pythagorean? Do I have ones and squares? I don't see any ones. I don't have squares, so I can't do that. do I have a conjugate set up? That's where you have like 1 plus or 1 minus a trig function in the denominator. And no, I don't. Can I transform anything to make it sines and cosines? Answer is yes. So what I'm going to do here is I see I have cosecant in the denominator. Let me pull up my formula chart. Sorry. I'm going to be using my reciprocal identities and possibly my quotient identity for transform. So here they are. Here are the three. Okay, so cosecant in the denominator. Cosecant in the denominator is equivalent to sine in the numerator. It's this reciprocal. So I can take this and shoot this to the numerator if I change it to a sine. So I'll have cos x, tan x, sine x, plus, and I want to do basically the same trick over here. I'm going to take secant and send secant to the numerator. Let's see, secant in the denominator is like equivalent to cosine in the numerator. So I'll have cotangent sine times cosine. Okay, I look and they're not identical here. We both have sine cosine, but this value has the second term has a cotangent, the first one has a tangent. I'm now going to convert that right there, by the way, was called reciprocal identities. That's what I did there, reciprocal. And I could go all the way through spot oil, but I'm just going to continue on with the T here. I'm going to put identities because I did it twice. Now what I'm going to state is that tangent, sine is y, cosine's x, tangent is y over x. Tangent is y over x, or sine over cosine, and cotangent is cosine over sine. So I'm going to rename, I'm going to put both of those. This is called the quotient identity. What I'm going to do is rewrite tangent as sine over cosine. And then over here we have, I'll do the same thing, but with cotangent. Cotangent is cosine divided by sine. That right there is called the quotient identity. And since I did it twice, I'll say quotient identities. Make it plural. All right, I see on the left term that I'm multiplying by cosine, dividing by cosine. On the right term, I'm dividing by a sine and I'm multiplying by a sine. So I believe I have here sine squared plus cosine squared. That I did a little algebra, I simplified. So that I went back, I've now started the spot oil and I went to simplify. So I've done transform twice with reciprocal and quotient. And now I'm back to, I did some algebra. And so I go through it and say, okay, well now I've done my algebra. I can't do any more algebra. Can I do Pythagorean? And the answer is yes. Sine squared plus cosine squared, we have squareds. So I would go to my Pythagorean, which here's Pythagorean. And I notice that sine squared plus cosine squared equals 1. And so that would be your solution. If you're doing Pythagorean, we find out all of this equals 1. And that is Pythagorean. Let me slide this over. Pythagorean identity. Oops. And so now that I have my answer over here, I can say answer is just 1. Let me see if I can zoom in somewhere in between where it was. Yeah, let's do it like this. Maybe this will help us see a little bit better. All right, number 11, it says find all asymptotes for the graph of y equals tangent x minus 4 in the restriction of 0 to 2 pi. Okay, this came from lesson 4.5. This was lesson 4.5. And so if I wanted to find asymptotes, what we learned is asymptotes always appear with a period of pi. But to find it, you have to think about what you're dividing by. So tangent we learned is y divided by x. This will occur anytime x is equal to 0. And so what we were doing last time is, I think if I remember right, I gave you 3 steps. Is the first one we would establish is where it would occur without any transformations. Okay, I can't remember my exact terminology, but we were looking for where is the first asymptote without any transformations. And so tangent would have an asymptote whenever cosine or the x is 0. Okay, so you can this would be y equal tangent is, let me write it this way. Y equals sine x over cos x minus 4. An asymptote would occur anytime that cosine is equal to 0. Or said another way, anytime x equals 0. And so I'm looking over here and I find out that x is 0 at this spot here, pi over 2, and this spot there, 3 pi over 2. That's where my x value is 0. It's right in the center of the graph at those 2 angles. We only take the first one when we found the asymptote. So step 1 was the first locate where the general asymptotes are. And so step 2 is we were kind of rewriting it, saying, okay, the asymptotes will occur, at x equals pi over 2 plus n pi. But then we'd have to come back and apply any horizontal transformations. That n pi just means they reoccur. They with the asymptotes, these trigonometric functions are periodic, which means they repeat after a certain period. For asymptotes, they repeat every pi unless there's any horizontal transformations, which this problem has no horizontal transformations. Remember, that would occur on the inside with the x, and this has none. So this would be where all asymptotes appear, where n is an integer. So I'm going to say NEZ, meaning n is an integer. That'd be my solution. Now, I think I created a little bit of a graph so you can see these and test it. Let's see here. Graphing trig functions. Yeah, trig functions with asymptotes. Let's open that up. Y equals, I have f of x here, and that's fine. Tangent x minus 4. And we want to say the first asymptote occurs at pi over 2. And the periodic would be plus n pi. That's exactly what we have. So let's see if this, oh yeah, it's working. If you look at my graph here, you'll notice that every time I move in, I'm getting a new asymptote. So it is cutting between that blue graph of tangent x minus 4 perfectly. This asymptote is splitting the different branches of the graph apart, or pieces of the graph apart. So we did do it correctly there. All right, now let me see how I need to write the answer over here. Oh, it doesn't ask, so I'll just write it exactly how I did write it. X equals pi over 2 plus n pi, where n is an integer. That's what NEZ means. N is an integer. That means a whole number. It's not like a decimal or anything like that, but it could be negative. So a whole number typically means positive. Integer means whole numbers plus the negative whole numbers. Number 12. It says find the exact value of cosine 15 degrees and sine 5 pi over 12. This also would be lesson 5.4. Not to be confused with lesson 4.5 right here. This would be sum and difference identities. We have a unit circle, but unfortunately 15 degrees and pi's over 12 are not located on them. However, I could tell you this. 15 degrees is between 0 and 30. That's where 15 degrees would be. And 5 pi over 12, that's almost 1/2 pi. Whoa, what's happening there? Let me go back. I'll try this one more time. 5 pi over 12 would be located right there. Now you might not know that. You don't have to know that. But that's where 5 pi over 12 would be located. When I went through this lesson, I told you, okay, with the radians, we'll do something special. The degrees is pretty easy. You just have to find 2 angles that are on the unit circle that combine somehow to give you 15. And I'm going to say 45 minus 30 would be 15. 60 minus 45 would be 15. 135 minus 120 would be 15. You can choose a lot of different ones. I'm just going to choose the first two. Now I'm going to say that cosine of 15 degrees is equal to cosine of 45 minus 30 degrees. Now that is a difference identity, which on our formula chart, we have, here's the difference, sum and difference identities. I'm dealing with cosine, so I'm looking at this formula right there. Hey, that highlighted it very well for us that time. So that's the formula I'm going to be using here. So I'm going to do a little substitution. And so we're going to say that cosine of angle A minus angle B is going to be equal to cosine A, so cosine 45, times the cosine of B, which is 30. Ignore the negative, that's just telling you which formula to choose, plus sine of 45, sine of 30. I go to substitute in here. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Plus sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. I see I have a common denominator here. Both denominators are 2 times 2, which is 4. I have square root of 6. You are allowed to multiply and divide square roots. However, you cannot add them, so these will remain separate. And that's just the square root of 2. So that would be my first solution. So cosine of 15 degrees is the square root of 6 plus the square root of 2, all divided by 4. And you can check that in the calculator. It should add up perfectly. Now, if I wanted to find sine of 5 pi over 12, what you'll have to do is get 5 pi over 12 written. Here's how I showed you how to do this in the lesson, as 2 different fractions. And to add, they obviously have to have a denominator 12. They have to be a common denominator. Not only that, in common terms, they both have to be amounts of pi. But to use our unit circle, there is no denominator 12, which means we have to have that denominator 12 reduce with the numerator. So I have to have 2 different numbers that add to be 5, but reduce with 12. So like 1 and 4 would not work, though they add to be 5. 1 does not reduce with 12. However, 2 and 3 would work, because 2 plus 3 is 5. So 2 pi over 12 plus 3 pi over 12 would be 5 pi over 12. That's true. And they both reduce. So I will no longer have the denominator 12. I could rewrite this as 2 pi over 12 is the same thing as 1 pi over 6. And 3 pi over 12 is the same thing as 1 pi over 4. And so I could say that sine of 5 pi over 12 would equal sine of 1 pi over 6 plus 1 pi over 4. And then we could go through and use this same formula, not the same formula, I'm sorry, same group of formulas, but specifically since I'm adding and it's sine, I would use this formula right there. So it'll be equal to, it's sine A cosine B plus cosine A sine B. And notice those are the exact same angles we were working with earlier, but now we are using the radians. So sine of pi over 6 is 1/2 times cosine of pi over 4 is the square root of 2 over 2. Cosine pi over 6 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. Notice again, I have a common denominator. And lo and behold, so 2 times 2 is 4. I have a square root of 2 plus square root of 6. Notice our answer happens to be exactly the same thing. So that means that sine of 5 pi over 12 equals the cosine of 15 degrees, which equals square root of 6 plus square root of 2, all divided by 4. And that's the end of page 2. So 12 problem is done. I told you we got 20. Let's go on to page 3 here. And I'm starting off with a trigonometric expression that we need to reduce. This came from lesson 5.2, where I told you to follow spot oil. So in this particular problem, you say, first, can I simplify? Is there anything I can cancel? Answer is no. Can I do Pythagorean? You look for ones and squares, which no, don't have any of those. Conjugate or opposite denominator. I don't even have a denominator, so I can't perform that. Can I transform anything to sines and cosines? Yes, I can. So the tangent right off the bat, I can convert that. So I have sine times tangent is y over x, or sine x divided by cosine. Secant, I can convert secant. That's 1 over cosine. Let me show you over here. Secant, where is it? There it is 1 over cosine. Plus a cosine. So let's see what I have here. It appears to me that I have sine times sine, which is a sine squared. And I have a common denominator here, sine squared minus 1 over cosine plus a cosine. These were common denominators, so I combine them. Now I come back over here and say, okay, let's go back to spot oil here. By the way, that was called a quotient identity. This was called a reciprocal identity. Quotient, reciprocal, and then I did a little algebra. Can I simplify? No. Can I do Pythagorean? We look for squares and ones. Yes. I have sine squared minus 1. So do a little mental math with me here, or imagine, what's the term here? Manipulating this equation with me. We need it to be sine squared minus 1, which means I would subtract 1 from both sides. So sine squared plus cosine squared minus 1 would equal 0. However, I want it just to be sine squared of minus 1. So that means I would need to subtract the cosine squared over. So sine squared minus 1 would equal a negative cosine squared. If you do a little manipulation, that's what you would get. So what can I say about this numerator here? That is congruent or equivalent to negative cosine squared. So that right there is negative cosine squared. So that was Pythagorean, and now I can do a little algebra here. I can cancel that out. So I have a negative cosine plus a positive cosine, and that also cancels out, or using a better math term, simplifies, and we're left with nothing. So my answer to this problem would be 0. All of that equaled 0. Let's check it out to make sure we're correct. So I go over to Desmos. I'm just going to clear out this stuff. And we're looking at the problem, sine x tangent times tangent x, sine x. Now you have to put in parentheses on Desmos whenever you have two trigonometric expressions that are multiplying. So I'm just put parentheses around the x's all the way across, though I don't need them all the way across, so specifically on the sine is where I really need it. All of that should equal 0. And as you notice, this line across here is going through at 0. So that is true. That didn't work, but it does equal 0. If I said y equals 0, y equals 0, you notice they're the same exact line. Y equals, if I put that, those two are exactly the same. So it is true that all that does in fact equal 0. All right, I'm now going to back it up just a little bit, back where we were. Whoa, all of a sudden it just seems so blurry. Maybe you should stay in there. I'm going to skip a few problems here. What I'll do is draw a diagram, but that's it. So this is a real world problem. With real world trigonometry, I like because you're usually dealing with positives. So we have a triangle ramp. So it's a ramp, but it looks like a triangle. And it says angle A is 59 degrees. So I need to make 59 degrees. I'm going to put it, the angles they gave, oh, it's not at a right angle at all. Let me redraw this. We have a ramp with one angle being 91, which is slightly more than 90. So there's 90. I'll just go just past it like that. Okay, so we have 91 degrees. That's our B. Our A is 59. It looks like that's the smallest. Let me go over here. I'll make this A. That right there would be 59 degrees. You could find this one by subtracting from 180. You just say 180 minus the 91 minus the 59 to get that angle. And you know that little c, lowercase c is 25 feet. C equals 25 feet. This would be a law of sines problem because I could have a completed set. I could just find angle C really quickly. I guess I might as well just, I'm this far, I might as well go ahead and solve it. I get 30 degrees there. So we could do law of sines because you have a completed set. And so let me go to Desmos here. Let me close off some of these other Desmos. I have so many open. Let's go to law of sines. And here's your formula. So we're trying to find lowercase b, which is this side right there. That's what I'm trying to find. And so I can say that sine of my completed set, which is 30 degrees over 25 feet, will equal sine of 91 over my b value. And so here we go. We have 30 over 25 feet, sine of 30 over 25 feet, equals sine of 91 over an unknown amount of feet. So I'll put an x. It says the answer is 49.99. I don't know if it says anything to round to, so I'm just going to leave it as 49.99, and this would be in feet. 49.99 feet. And that's how we do that with the law of sines. You could cross multiply and divide if you're using algebra. Cross multiply, butterfly technique. Cross multiply and then divide. Number 15, geometry. It says, Miss Lindsay designated a triangular area in the auditorium for art projects. The dimensions of the triangle are these three dimensions here. What is the area of the triangle? Okay, we had a formula for this as well. It's called Heron's formula. I believe this was lesson 4.7. So I have a triangle. I don't know anything about the by the way, I forgot to put, this is 4.7 here. This is 5.2. I did write it on that one. 5.2. Okay. I believe this is also 4.7. I'm not 100% certain of that, but I believe it is. Okay, my longest side here is 48 feet. Oh, wait, it says right here. Yeah, it is 4.7. Okay, my shortest side is 31 feet. And this middle length is 45 feet. What is the area of the triangle? Well, if you remember, there was a formula for this, and I created a calculator for it. If you go to Heron's formula, that's what it's called, area of a triangle. And I actually have Heron's formula, and there's another formula that uses sine function to calculate area as well. So depending on what you have, well, on this one we have 3 side lengths, which would be lowercase letters. So we'll just put them in the order that they gave it to us. The dimensions 48, followed by 31, followed by 45. And I put them in the lowercase because they're side lengths. And this tells us, according to Heron's formula, that the area is 676. 676 point, and I'll go 34. And this would be feet squared. So Heron's formula, the way it works is you first have to calculate half the perimeter. They use a lowercase s for this. I think this is also in the formula chart. Heron's formula. Zoom out a little bit. There it is right here. So there's Heron's formula, where s is half the perimeter. So you would first have to calculate that. So you'd go 45 plus 31 plus 48. So you calculate half the perimeter, and then you would plug it into this formula that would say s, your half the perimeter minus times half the perimeter minus each side length. So 48, half the perimeter minus 45, and half the perimeter minus 31. The order does not matter. I realize I just went out of order on these two, but you would type all that in and you would get that answer for your area. All right, number 16. So as it says on the side, this is lesson 4.3, the unit circle. It says point P is located 120 degrees counterclockwise around a circle with a diameter of 20 meters. So the diameter here is 20 meters, which means the radius would be 10 meters. There's point P, it should be prime, is 120 degrees rotated. If the center of the circle is at the origin, what coordinate represents the location of P prime relative to the center? Okay, oh, wait, no, I'm sorry. I see point P is original, then it's rotated. Okay, so where would that location be? Well, if you use your unit circle, which I had one of those on the previous page, let me just add in another one. 120 degrees is located at this point. But what we're saying on ours is it's been stretched, if you will. Our radius on a unit circle, the radius is 1. And so that's a radius value of 1. But we're saying the radius value is 10. Whoops. Let me go backwards. So on this problem, the radius is 10. So if I use my unit circle, let me just put it right here, make it really small, so you can kind of get an idea what I'm doing. All you'd have to do is multiply that value by 10. Okay, so I'll just throw that in there for later. And so it would be 10 times, and I'll distribute this point through, negative 1/2. This is for P prime, time, and square root of 3 over 2. And I would distribute the 10 through. So both of them are being divided by 2, but multiplying by 10, I can simplify both of these. And so it'll be really nice math. So 10 times negative 1/2 is negative 5. 10 times square root of 3 over 2 would be 5 square root of 3. That would be my solution right there. So when I come back, and again in meters as well, so it'd be left 5 meters, up 5 square roots of 3 meters. I'll just put meters on the outside. Actually, I'm not sure with coordinates if you'd have to include that, but you just need to know units on the graph would represent meters, but that would be the point. Number 17. Now this is lesson 5.3. So what the difference was in lesson 5.3 from 5.2 and 5.1 is not only were we simplifying, we were actually solving. And for most students, solving was easier because you got to do a lot more algebra in comparison to what we were doing in the previous lessons. So when I work through number 17 here, it says 3 tangent squared x plus 2 square roots of 3 tangent x minus 3 equals 0. And that's what we're supposed to solve. Now, the way I did it on lesson 5.3 is I told you, hey, if you're going to solve this using algebra, just think of solving it without the trigonometry just for a second. If you had 3x squared plus 2 square roots of 3 minus 3 equals 0. Now, a lot of us would ask ourselves, okay, how could I do that? Well, it looks like I have quadratic here, so I'll do x method. The problem, oops, I forgot my x. There we go. The problem with quadratic right now is that we don't have a rational b. So if you tried, I said problem with quadratic, the problem with x method is that when you do the a times c, what you would end up with is -9, which is great, but your b value is 2 square roots of 3. And so you'd have to come up with something that's not using radicals to come up with this 2 squared to 3. And that's a little bit trickier. So what I'm going to do is use the quadratic formula, which is on here on the formula chart. I'm just going to have to find it real quick. We're looking for the quadratic formula. There's the quadratic equation is what I'm working with, but I want the quadratic formula, which is there. And that's just showing you how to solve. So what this is saying is that the solutions for x, but in our problem, it's not just going to be x, it's going to be tangent x will equal negative b. There we go. Negative b, which is negative 2 squared to 3, plus or minus b squared, 2 squared to 3 squared, minus 4 times my a, which is 3, times my c, which is negative 3, all divided by 2 times a. Okay, so we go to solve this. Negative 2 square root of 3 plus or minus square root. Okay, when I squared this, 2 squared 3 times 2 squared 3 would be 4 times 3. Square root of 3 times square root of 3 is 9. I'll just write it like that. 4 square root of 9. This 2 negatives will become a positive. 4 times 3 is 12, times another 3 is 36, all over 6. Let's simplify that again. I'd recommend just going to Desmos and typing a lot of this in, but since I'm this far along, I'm going to keep on going. So what do I have here? That's 12 plus 36 over 6. How did I get 12? That's a 3. Square root of 9 is 3. 3 times 4 is 12. And so now it looks like I have negative 2 square root of 3 plus or minus square root of 48 all over 6. Okay, let's think. 48 is the same thing as negative 2. 48 is the same thing as the square root of 4 times the square root of 12. Actually, I can pull out more than that. 12 is the same thing as square root of 4 times 3. So that's the same thing as 4 times 3. 16, 48, that's true. All this over 6. So negative 2 square root of 3 plus or minus, that's 2, that's another 2. 2 times 2 is 4. All this over 3. So when I go to simplify this, I can take away, I can divide everything basically by 2. Just takes that away and changes that to a 2. And so I would have, as my possible solutions, that tangent x could equal a negative square root of 3 plus 2 square roots of 3, which would be 1 square root of 3 over 3, or it could equal a negative square root of 3 minus 2 more square roots of 3, so negative 3 square roots of 3, all divided by 3. So it could equal those values. So what does that mean about x? Well, when I take the inverse of square root of 3 over 3, and these would produce my answers. Let's come over here to the unit circle. This problem is getting longer and longer here. And we'll try it with the calculator here in a second. You remember it's y over x, so this first one will be easier to solve. Y over x has to be negative, so think of a negative square root of negative y of square root of 3 and a positive 1. So this spot would be a good answer. But it also could be a negative 1 and a positive square root of 3, which is over here. Sorry, y over x, there we go, which is those 2 points would work. Is there any restriction on, let me see here, for all values of x? Okay, so since those are pi apart from one another, you could actually just list it once. So this answer would be, since it says all values, it would be x equals, this comes from 2 pi over 3 plus, and I could just say n pi because tangent will repeat itself. That's the first answer. Now this answer, let's see, square root of 3 over 3 comes from the unreduced form of saying 1 over square root of 3, like that. And so now I'd be looking for the x, or the y being 1, the x being square root of 3, but both positive or both negative, which would become from here and here. No, that's backwards. Here, y1. Okay, so it'd be these two locations. Again, they're 1 pi away, and so this one would be pi over 6 plus n pi. You only have to list it once. Those two would be my solutions. Okay, after showing you all of that, could we have solved this with a calculator? You bet. Let me get a blank. Three tangent squared x plus 2 square root 3 of tangent x minus 3 equals 0. So I first type in the graph as it is, and then I'm going to type in y equals and just put the left side of the equation, and then y equals the right side, which is 0. The intersections of the graph should be the solutions or the red lines. Okay, if you notice, the very first solution's at pi over 6. The second answer is 2 pi over 3, exactly what we got. The other values would be repeated that are not on the unit circle. 7 pi over 6. Well, no, it is. I'm sorry, but it's n pi away. So 7 pi over 6 is on there. We had that one circled somewhere. There it is, 7 pi over 6. As well as, oops, not 13 pi over 6. That's not on there. 1, 2, 3, 4. There's the first 4 that you see. Pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. There's our last one. So those are the ones we circled. These would be the first that occur, and they occur every n pi, which means this plus n pi gives us 7 pi over 6, or plus 1 pi, I should say, not n pi. This one plus 1 pi gets me over here, 7 pi over 6. They're on the same line. If you notice it, that means you just add 1 pi to get across. So that was a really long problem. The calculator could have done it for us very quickly, though. All right, let's see. I got 5 minutes. That's not very long for the last few problems. So I'll go as quickly as I can to at least get 18 and 19. And I'll let you figure out, this is dealing with algebra. Remember, slope is rise over run, so that's telling you your y over x. So I'm going to give you that little hint for 20, but let's get to 18. It says basically have this solution. I'm not going to read it because I have the diagram, and it says to solve. So this is north 71 east. So you start north, you go 71 to the east. This is from the chapter 4 applications. And then it says for you, that means chapter 4 applications. This one starts north, goes 41 to the east. We need to find that. Okay, let's kind of think about this triangle here for a second. That's a 90 degree. So I could actually state that angle right there is 90 plus 41, which equals 131 degrees. This angle is 71, but it makes a 90. So this angle is 90 minus 71, which is 19 degrees. We can now solve for this angle by saying 180 minus 131 minus 19. That's 150. That would equal 30 degrees. I have all angles, which means I can do law of sines because I have a completed set here. So I'm going to go to my calculator and do law of sines. So I start with my completed set. So I'm going to say sine of my 30. This is my completed set here and here. That's my pair. I have the angle, it's 30 degrees over the side length, 205. Will equal, and that's in miles, I'm looking for this pair, which would be sine of 131 over the unknown, which we'll call it x. All right, so we type in our values. We have sine of 30 divided by 205 will equal sine of 131 divided by x. The answer is 309. You'd have to zoom out to see it right there, but it says 309.43, and it says round to the nearest tenth of a mile. So to the nearest tenth, if it's one decimal place, it would be 309.4 miles. And let's see if we have enough time to do the baseball problem. So it says here in a baseball game, a ball is hit on a north 48 degrees east. That means starting north 38 to the east line. So the ball's hit here to the right field wall, 372 feet away. So this part of the triangle is 372. The player in right field must make a throw to third base. So they throw it all the way to here. The question is, how far of a throw must a player make to reach third base? Round to the nearest foot. Okay, so in our triangle that I'm looking at here, and let me make it more obvious to you what my triangle is. This is my triangle. We're told this is 90. This is 372. This is 38, and this does not make a 90, but the baseball field itself does, which means that's half of it. So this is a 45 on this side, and that's a 38. So this angle right there would be 45 plus 38, which equals 83 degrees. 90 would go from here to here, by the way. That's the 90. Okay, so that's 45. I don't know this angle here. That's less than 90, nor do I know this one. So I don't have a completed set this time. So I need to use the law of cosines. So I'm going to pull up the law of cosines. Let me see if I can get it in before the bell rings. What we know is we have this angle. It's 45 degrees. That's capital letter. We know two lengths that are not across from the 45. So we know that's 90, and this is 372. The unknown is the length across from my angle, and this says the answer is, and we're supposed to round to the nearest foot, 315 feet. My answer here would be 315 feet. And that's using the law of cosines. Oh, I put the wrong angle. That's wrong. That's not, angle wasn't 45 degrees. It was 83. Sorry. Let's change it. 372 feet. How about that? We're going to change it and say that's wrong. It's 372. Now I corrected myself. 372 feet. So sorry about that error right there. And what I'm going to tell you about the last is on this last problem, you would use rise over run for slope. So it says you have, I know the bell's probably going to start ringing here in just a second, but here it says you have a line that has a rise over run of 3/4. So that means it goes up 3 for every 4 it goes over. So something like this, where I'm just going to mark this, where that would be an x of 4 and a y of 3. Because this is rise over run, and that means it's y over x. Okay, so it says there's the terminal side of an angle in quadrant 1, and you remember your theta always goes in the x-axis, so you have a triangle that comes in here like this. That's your triangle. It says find cosine. Cosine is x over h. So this looks like it's going to be a 3, 4, 5 triangle. So that would be an h of 5. And so cosine would just be x over h. So my answer would be 4 over 5. And that would be number 20. So take care. Good luck. Make sure you take this Friday or earlier if you want. But that's your review.